Standards SP1, 2, and 3 all have to do with scatterplots. This first standard is basically an introduction to scatterplots. Problem number 1, the scatterplot shows the number of visitors at an art show in relation to the admission price. What does the point A on the graph represent? So we look at the graph and we find point A. We see that it represents admission price of about $20 and that the art show attendance, that would be the number of people, is somewhere between 100 and 150 people. So we can just put that into words and say, what does that mean? It means that when the ticket price was $20, about a little over 125, so maybe about 130 visitors attended the art show. Looking at part B, what type of relationship exists between the admission price and the number of visitors? And it's talking about linear associations, and so we have to think about what that means. But basically, if you can draw a line through the points that are there, and it's generally close to the points, it's a straight line, you have about the same number of points above and below the line, and it just kind of follows the path of them, then that indicates it's linear. Since it's going down to the right, like slope goes down to the right, that indicates that it's negative. So B, it's a negative linear association. Number 2, what is a scatterplot? And this is just a definition question, but a scatterplot is answer choice C. It's just a display of points that shows the relationship between two different sets of data. Number 6, Eric recycles bottles at the local recycling center to earn money for a new bike. Eric keeps track of how much he's earned in this graph. Part A, identify any outliers. So an outlier is going to stand out. It's going to be a point that doesn't really seem to line up with the other points. And when we look at this, we could say this point is far away from the data. So this is called an outlier. Part B, what kind of association is there between the number of bottles Eric collects and how much money he earns? Well, if we were to try to draw a line through those points, we would get something like this. Might redraw it. Be something like this, more or less. The line would follow a path through the points, and it goes up to the right, and it does follow a linear path. So this is going up to the right, so that makes it positive. And it follows a line, a linear path, so it's a positive linear association. Part C, what does the point labeled F mean in the context of the graph? So looking at point F here, and that represents the ordered pair 5, 10. That means that for every 5 bottles collected, he earns $10. So he earns $10 for collecting 5 bottles. Standard 8.SP.1-3 still is talking about scatterplots, but this standard is focused on trend lines. So we're going to look at this problem number 4. Can you use a trend line to describe the relationship between the two sets of data for this graph? So when we look at this, these points appear to be all over the place. Can we use a line that represents these points? No. No, we cannot. There is no association between these two data sets, which would be between the number of ladybugs and houseflies. Number 5, draw a trend line for the scatter plot. And then what type of association does the trend line show? Well, I could draw a line that's going to go follow a path of the points. It's going to go with about half the points above and about half the points below it, pretty close to it. It's not exact. This is like an estimate. And what type of association is this? Well, it is going up to the right, so it is positive. It does follow the path of a line, so it is linear. So it's a positive linear association. Number 6, which type of association does the scatter plot show? Well, it does not appear that we could draw a line showing what's going on here. But what you might notice is that it starts out with over time, it starts out with the height of the ball being lower, then the height of the ball increases, then it goes back down. So this forms what appears to be a parabola, and that would be a non-linear association. It does not follow the path of a line. Standard 8.SP.1-3. This is about modeling trend lines. They're in the form of y = mx plus b. We could see them in an equation form. We could see them on a graph. We're going to look at problem number 3. The graph below shows the number of beehives per acre compared to the pounds of blueberries harvested on a blueberry farm. The equation of the trend line is y = 2/3 x plus 4,000. Predict the pounds of blueberries harvested for 7 beehives per acre. Sometimes we need to go to the equation, and sometimes it gives you a graph that you can just look at. We see 7 beehives per acre here. We want to know the pounds of blueberries in thousands of pounds. So if you notice here that at 7 beehives, we could actually draw a line and go across and see that is going to be somewhere between 8 and 10,000. So it's going to be close to 9,000 pounds of blueberries. It maybe be a little under 9,000, but it's certainly going to be more than 8,000. And so we were able to just use the graph. Number 4, the scatter plot shows the distance a car is driven compared to the thickness of the tire treads. So as a car is driven more, the tire treads get thinner because the tires are wearing down over time. So what is the y-intercept and what does it represent in this situation? So we know that the y-intercept is where x is 0. So we go to where x is 0, and we got this point here, b is 25. So the y-intercept is 25, and it's measured in millimeters. And this is just showing that the tread thickness starts at 25 millimeters for a new tire. Okay, we're going to use items 9 and 10, we're going to use the scatter plot. The scatter plot shows the time required for residents to descend the flights of stairs in their apartment building. Predict the time needed for a resident on the 4th floor to descend the stairs. So, let's take the 4th floor, that's 4 flights of stairs, and go across and see how much time that would be. It would be 2 minutes. Just using the graph, picking out an ordered pair on the graph. Eddie does not want to take more than 3 minutes to descend the stairs. What's the highest floor he should live in? So we go over here and we think of where 3 minutes would fall, halfway between 2 and 4. And we're going to go across to our graphed line, our trend line, and go down and see what x would be the flight of stairs. And at 3 minutes, he could be on the 6th floor. So that is the highest floor that he should live on. Any higher, and it would take more than 3 minutes to descend the stairs.